Let's try this. Permission denied by system. I may need somebody else to pull the slides up because I am getting a permission error from Meet Echo now when I try to share the screen. Let me try one other approach. My apologies for those just joining. We're having some slide issues, but we'll be on with the meeting in a minute. Okay, how's that looking? Can people see the title slide?
Right now.
Awesome. Okay, I'll have to do that for each of the slides. All right. So welcome. It's 9 a.m. here in Pacific time. I think it's time to get started. I see we've got a healthy debate upon what you call ADD participants. Adders has been taken off the choice list. And how many we got? 51 participants. Okay, and we've got the various co-chairs are here. Looks like it. And we've got Ben, who's going to be our one set of slides for today. So let's get started. Welcome. This is a joint interim meeting between ADD, DNSOP, and DPROD. Be aware this is, and I got to change the slide here. Be aware this is an IETF meeting, and as such is covered by the NoteWell set of rules. Please be familiar with them for your participation. I'll also add that this is covered by the sort of informal ADD set of rules, which is be kind to one another. Even if you disagree, be kind in how you disagree. We get a lot more productivity out of all of us when we are kind to one another. So
that's not just an informal ADD rule. This is a modern guiding principle of the IETF. So.
And it will be enforced formally, even if it is informal. And let me bring up here the main agenda for today. Sorry, forgive me, I'm doing it as a tab. All right, and then I'll stop sharing that one. And I'm going to share this one. Is that big enough for everybody? Forgive me, I'm I can't see what you see. So what do you see right now?
The agenda?
Oh, perfect. That was the goal. I'm glad I achieved it. Let me bring it over here. So welcome. I'm Glenn Dean. I'm one of the co-chairs of ADD, along with David Lawrence. This is joint, so we also have the chairs of DNSOP and DPRIVE, and I'll give everybody a chance to speak in a minute, along with our area directors, Warren Kumar, who I misspelled Warren's name. My apologies to Warren, and Eric Vink. The goal today, so we've done NoteWell. We need a scribe. Do we have anybody volunteering to help be a scribe for today's session? And it's okay to have a couple, one to sort of take the main notes and somebody else to fill in when they're getting behind or correct things. And we can't proceed until we get a scribe. So a volunteer is really welcome.
Oh, so Glenn, I volunteer to take notes. In the head doc. Yep. thought I'd
Thank
send
you,
that
Tim.
email.
Yeah.
Yep.
Okay, so we have a slide. We have a thread, and can we get a volunteer to sort of be the one to follow the chat in Jabber and bring up any issues to the group? So
Yes, I can do that, Benno.
thank you very much. Okay, so the agenda's been posted for about a week. Do we have any bashes for the agenda? Things that people want to add or remove? This is the first part. The reading about the background on this discovery topic. Then we're going to break into a discussion with initial presentation by Ben Schwartz, talking about a proposed approach on a few of the issues around the split DNS and discovery for it. This is a presentation light, discussion heavy session. So it is going to be essentially focused around the mic line, and the topics we put up here are going to be to prompt you to have conversations around these topics. If there's additional topics, feel free to bring them to the mic line. This is an open discussion for us to move forward on the mind thinking here, the consensus building. So any changes people want to propose to the agenda? Okay, fantastic. Well, then let's get to the welcome from the chairs. So do we have somebody from DNS Op? Suzanne, are you on? Do you want to say a few words?
Okay.
Anybody else?
Yeah, Suzanne was
Yeah.
Suzanne was planning to do that, but she was called away. So I fill in here. So welcome, DNSOP participants. So as I think that DNSOP chairs already mentioned earlier that before IETF meetings, the DNSOP ADD and deprive working groups chairs are sitting together, discussing ongoing matters, discussing topics that might be of interest of each other's working group, and make sure that it gets attention in the different working groups. This is one of these topics, the DNS split. So yeah, we're looking forward for participation of the DNSOP participants or the participant members. Oh, sorry, DNSOP members. And yeah, give their perspective and their clue on the topic being discussed today. That's it from the DNSOP chairs.
And would one of the chairs of Deprive like to?
Oh, that's me. Yep, that's me. I was actually going to add to that. The discussion around split DNS is it's definitely more of a DNS. It's a topic that's near and dear to a lot of the DNS op folks, and I think some of the stuff that's going on, especially with what you're using to try to key on things or flag things, definitely sort of falls. There's definitely some deprive pieces here, or they do seem to overlap if you sort of look at it in that sort of way. It's probably the right way to put it. It may not be the right way to looking at it, but they do kind of look that way. So that's all I'm going to say.
Eric, would you like to say some words from the perspective of the ADD AD?
Deprive and deprive, don't forget. Yeah.
Oh, yeah.
So basically very short, Glenn. So first, thank you for all the chairs to come together and all the participants of the working group. It really means to believe that we may need to see whether a DNS directorate could be useful at some point of time to gather the interest. And the other part is more like a logistic. Warren told me it will be late by 15-20 minutes, so don't expect him into the beginning of the meeting. And let's have a nice meeting.
Thank you, Eric. So, Tail, do you want to say a few words before I jump in, or?
Just hello, all you wonderful standards concerned fellows. Thank you so much for taking time out of your day to come here and discuss this particularly thorny problem with us.
Thank you, Dave. So how this is going to work today is I'm going to play the role of your master of ceremonies, which basically means I move the agenda along as we go. And when we seem to get on a topic where we get to a place where we're sort of got nothing new to say on that particular topic, we'll move on to the next one. Mr. Lawrence is going to manage the mic queue so that way we'll know who's supposed to speak and when. And other than that, we're going to sort of jump in. Let me introduce a little bit about the background for this. And this is largely for maybe people that haven't been following the ADD list very closely. So ADD has been working on the discovery mechanisms for encrypted DNS servers, whether they be DOE or DOT. And we've got a couple of mechanisms now that are, one is really well suited for the open internet, and it's uses the records and publish the URL within the DNS. I encourage people to go read that draft, and they're linked here in the bottom, the draft number 1 and 2, discovery designated resolvers, and then DHCP and router advertisement. So this, the DNR is an approach for how you do it in environments where you're either using DHCP or router advertising. And they're documents that are fairly mature along the way. We, in the discussions of the group, hit a bit of a a bit of a wall. We, as a group, have decided that the problem of doing discovery in split DNS environments is important. It's an important one to solve. One of the worries, of course, is that if we do nothing in that environment, knowing that the environments are themselves very prevalent in operational spaces, in enterprises, organizations, many other places. If we do nothing, then ultimately that community will figure out how to do their own discovery mechanisms, and there'll be a bunch of ad hoc ones, not standards-based. And once you get that genie out of the bottle, it's very hard to put it back in and come up with a discovery mechanism that is standards-based. And so the group has said it's important as a use case to solve, but we had a document which came pretty well-written, very mature document as well, but that which failed to get adoption through a consensus, the consensus call for working group adoption. I'll note, however, the group didn't reject that document's approach and hasn't said this is a terrible document. I would more characterize it as we were not ready as a group necessarily to adopt that. And there was a bunch of issues raised around the discovery needs in a split DNS environment. A lot of them around things like validation of the resolver's authority to serve out those domains, validation of the answers that would come out of them. There was even discussion about the potential role and use of Dnsec in some of this problem space. And so we realized there was a bunch of these topics which were very much out of scope of ADD, which was only focused on the discovery question, how do you do discovery? These other topics were beyond us. And so this is sort of the genesis of this discussion of, well, what is needed in this environment? What should be considered by ADD? And then hopefully the goal here is that we get to a place where we have those questions, some consensus around them, and that the ADD group then goes, okay, now we know how we think we should move forward and what features and behaviors need to be in a discovery mechanism for the split DNS environment. Okay, so hopefully that sort of tees us up for the conversations to come forward. Moving on. So acknowledging that split DNS is widely deployed, we're not here to discuss how to get rid of that environment. We're not here to do a referendum on the practice. Some people hate it. A lot of people love it. A lot of people hate it too. But accepting that it's there, and if we do nothing, this is a genie that will get out of the bottle on how to do discovery. Let's move on and talk about this. So we're going to kick off with Ben Schwartz, who, along with a bunch of other people, and Ben, I assume we'll have them mentioned on his title slide, has put together a presentation. We're going to give about 20 minutes for this one, followed by discussion. And then we'll move on to the other topics that are around this topic space, as you can see in 2.2 and 2.3 in the agenda. And hopefully that'll take us up to about 5 or 10 minutes before the end of the meeting, and then we'll have a quick wrap up and see where we're going. And that's about it. So Ben, how about I turn control over to you, and we'll see your presentation. Hopefully we'll get the creative juices going. And let's see. I will stop sharing my screen. And Ben, are you able to take control now?
Share button should start working. There it goes.
Okay, do you see slides? Does anyone see slides? Can anybody hear
Yes.
me?
Yes.
Okay, great, let's get started. Hi, everybody. I'm Ben Schwartz, and this is a presentation based on that non-adopted draft that that was just mentioned. But this is not a presentation of that draft. This is a presentation of really the background material, talking about what Split Horizon DNS is and some thoughts based on the work that we did to try to put together a solution. But this is not about that solution. It's meant to provide us with food for thought for this discussion and maybe some shared definitions to work with. So to start, what is Split Horizon DNS? There are a lot of different ways to define this. I'll just give you the one that works best for me, which is that the network provided resolver gives you answers that are meaningfully different from the answers you would get if you just went and asked any other general purpose resolver. Meaningfully different is not an objectively defined phrase, and so it's not always clear whether you're doing Split Horizon DNS. It might be a matter of opinion. But if the difference is meaningful to you, then I'd say that's Split Horizon. And there are a bunch of different reasons people do this. People do this to create corporate intranets with domains that are only resolvable from inside the network. People do this to have a domain that exists on both sides of the network, but behaves differently depending on, resolves to a different version of that domain. Or sometimes it's just an optimization, but it's a very pointed optimization, like putting a high traffic server physically inside the network and making sure that that's the result you get if you try to resolve the domain from inside that network. So this is used in many different kinds of networks. One thing I didn't mention here actually is infrastructure uses of Split Horizon DNS among servers. That's something I'm a little less familiar with, but there are a lot of different reasons that people like to do this. So that's the basics. Let's also talk about DNS hijacking, which is kind of the dark side of Split Horizon DNS. So DNS hijacking here, we're saying, is answering queries for a name when you do not have authorization to do so from the zone. And again, authorization here is not meant to be a technical term. This is a human term. And so whether something is DNS hijacking might depend on the social nature of your relationship with an actual person who owns that zone. DNS hijacking is not allowed within IETF standards. I think that's clear both from general architectural principles in RFC 2826 and also on a technical basis from Dnsec and many other documents that talk about what it means for DNS data to be authentic or for a delegation to be authorized. So the obvious example here is answering for a domain that exists when you don't have permission from the zone that contains that domain legitimately. But there are also interesting variations on this. One of them is NX domain hijacking. So that's injecting an answer for a domain that would be NX domain if you actually resolved it to the authoritative owner. And a version of that is inventing new fake top-level domains that don't actually exist. In that case, you're doing NX domain hijacking in the root zone. And then maybe a new term that I found helpful to think about this space was that if you're doing Split Horizon DNS and you're not DNS hijacking, then you are doing authorized Split Horizon DNS. So the local resolver has been authorized by the zone owner to actually serve these local answers. Okay. Another thing we have to talk about if in this space is that we're going to bump up against some intractable topics. We're going to bump up against some topics that are essentially out of scope for the IETF or are not really things that we can solve here. One of those is the nature of trust relationships, because sometimes devices are connected to networks and they're managed by different entities that don't have a high degree of mutual trust. And when that happens, each of those parties is going to have its own policies that it's going to apply to the systems that it controls. Probably each party is going to make those policy choices based on things like their security assumptions. And so they're going to make those choices independently. And it's, at least for ADD, although this session is a little bit interesting because it's not clear if this is just an ADD session, but certainly in ADD, making any recommendations about those policies is strictly out of scope. In general, I think that standards development is not a place where we can get people to change their security assumptions. And if their security assumptions are not compatible, then they're not going to work well together. That's not something that we can really solve. We are in the business here of providing technical solutions for people who actually do have compatible goals and do want to work together. And so my plea to the session today is to focus on use cases where all that's missing is a technical solution, and try to not focus on the situations that we just really can't resolve ourselves.
Ben, Michael Richardson has a question. Do you want to save them for the end, or can you take one right now?
I can take a question.
Okay, go ahead, Michael.
Hi, Ben. I think this is a very important slide and a very important thing. And I think that one of the things often is that people think that they have compatible security assumptions because actually their terminology is overloaded and incompatible. So they both think they have a banana, but in fact, one of them has an apple and the other one has a potato, right? But they look like the same color, so they think that's a banana. And so I think I'd like to add a point here, which is that there are some use cases where the thing that is missing is an accurate technical description, and then it would be obvious that we have an incompatible security assumption.
Thank you.
Would you include that as a in focus then?
Absolutely.
Good.
So how do we make progress? In my view, the way we can make progress here is by looking for situations that are technically interesting. So we can think about the effects of different policies. We can look for combinations of policies that might exist, and then when those policies happen to apply, then there's a technically interesting problem to solve. So for example, if the client is always going to use the networks resolver, then it's always going to see split horizon names. And if the client never uses the networks resolver, it's never going to see those names. These are boring cases. There's just not much technically interesting to do in either of these cases, in my opinion. Although I'm, after the slides, we can certainly talk about that if people disagree. But I think there might be an interesting technical case for clients that sometimes use the network provided resolver. But to talk about that, we need to, I think, introduce another new term. At least this is how this helps me to think about the problem. I call it a hybrid resolver. First, I want to show you these puzzle pieces. I'm sure this is a little weird for people who didn't look at the slides in advance, but this is my attempt to give you a conceptual model of how DNS resolvers are composed. So we have these different building blocks, things like asking a DNS question, providing an answer, sending a query or an answer over a response over the network, accepting a query over the network and parsing out the question, taking a question, serializing it into a query, sending that over the network, and then the very complicated business of iterative resolution with multiple network paths. So this will become clearer on the next couple of slides. So if we take our question source and plug it directly into a remote answering function, which sends out our queries over the network, I think that's what we call a stub resolver. And if we take our network front end, which accepts queries over the network and parses them, and then forwards that, sort of reserializes that into another query and sends that along a different path, that is what we call a DNS forwarder. If we accept queries over the network and then turn those into questions and then perform iterative resolution to resolve the answers to those questions, that together is called a recursive resolver. If we just answer them locally, that's an authoritative server. This is my mental map of DNS functionality. Why am I giving you these building blocks? Because I want to introduce a new one, the idea of a question dispatcher, or you can think about this as a question policy that takes in a question, a DNS question, and potentially does something different with it according to some local policy, has at least two different behaviors that it might apply. And so I submit to you that hybrid resolvers are actually everywhere. Almost all of the things that we call stub resolvers or recursive resolvers, or at least a large fraction of them, are actually a little more complicated. They're actually hybrid resolvers. Here's some familiar examples. If you have a POSIX style stub resolver that sometimes answers DNS questions directly out of Etsy hosts without ever serializing a query, but sometimes it actually, most of the time, it forwards the queries to some upstream resolver. I submit that this is a hybrid resolver. It's not strictly a stub because sometimes it answers the question locally. And I've sometimes heard the term authoritative resolver to describe this. If you're running a DNS server, so it accepts an incoming query over the network, and maybe it answers it locally out of a zone file, or maybe it actually performs iterative resolution and asks other authoritative servers. Again, I would say that this is a hybrid resolution behavior. So with these concepts, we can now put together, I think, a clearer definition of what the interesting case is here. And that is the case where both the client and the network provided resolver are actually hybrid resolvers. So the network has to be a hybrid resolver because otherwise it's not doing split DNS. Essentially a hybrid network resolver that sometimes serves answers locally, like out of a zone file. To me, that's sort of the definition of split horizon DNS. And as I mentioned earlier, for there to be something interesting to talk about here, I think that we need to talk about clients that sometimes run their queries through the network resolver and sometimes are able to answer queries some other way, maybe by another remote answer behavior that forwards queries to a different upstream resolver, or maybe even local iterative resolution. It doesn't really matter. But to me, this is the interesting case because the question then becomes, how can the client and the network cooperate so that the client gets access to the network's local zone or local zones without within the parameters of each party's threat model. So now let's talk a little bit in more detail about the scope of our conversation. It seems to me that there are a couple of things that we can easily do, that we can do as standards development actors. The easy thing is we can enable clients to learn about the split horizon names that are available on this network. The hard thing, but maybe possible, is to enable clients to distinguish DNS hijacking of those names from authorized split horizon DNS, where the network provided resolver actually is authorized to serve those names. So the easy part of just conveying those names, we actually have a lot of good tools for this already. So provisioning domains defines an extension for this. To be clear, provisioning domains doesn't authenticate the contents of this in any way. What provisioning domains does offer is identification of the source of the provisioning domain claim. but it's not necessarily true that there's any trust relationship there that would allow that party to make claims about what DNS zones it should control. There's a standard for split DNS configuration for IETF-ADD-2022, that's VPN configuration. And the nice thing about VPN configuration is that there is actually usually a pretty close relationship between the client and the tunnel operator. There's usually, not intrinsically, a certain amount of trust there. And so this draft actually affords a lot of power to the tunnel operator. It even lets them override Dnsec trust anchors for the client, but it also assumes that there's a certain amount of user confirmation, some sort of not very clearly specified whitelist. But so that's the state of the art for VPN split DNS. And finally, even the old DHCP search option is actually very close to what PVD offers. Really, this is just the problem of distributing a list of domain names to clients on the network is not that hard to solve, and it maybe is already solved. But the hard part is how to confirm authorization of those names. So what would the client need to confirm that that local resolver is authorized to serve a given DNS zone? So here's my personal view of what it would take. The client needs an identity for the local resolver. And normally in classic DNS configuration, the client doesn't really have an identity for the DNS resolver. If in DHCP, in IPv4, all it would have is an RFC 1918 address, which is not really much of an identifier at all. Another thing it would need is an assertion by the zone owner that it authorizes the local resolver to serve this zone. So presumably we have to imagine that somehow the local resolver has a name, and then the zone owner can assert that that name is authorized to serve the zone. But if you fetch that assertion through the local network, then the local network could be tampering with it, could just forge that assertion. And so we need some way that the client could somehow convince itself that that assertion was not forged. And finally, we would need a secure transport to that resolver so that we actually know that we're talking to the entity that was authorized by that assertion. In classic DNS, we didn't have any of these four things. And so it was kind of a lost cause to try to do authorized split DNS, or maybe we could call it authenticated split DNS, where the client actually confirms that authorization. But there's been some progress in DNS security over the last few years. We have encrypted transports for DNS, and with ADD, we have a bunch of new drafts about how to do more secure bootstrapping and bootstrapping of those secure transports. So, and this is the only time I'll mention this draft. This draft found some pieces that you can put together to cover these four things. And this isn't the only way. On each of these four things, there are many different ways you could imagine. But what this draft said is, look, the DNR draft, which is adopted in ADD, actually does provide you with an authentication domain name for R. And it tells you how to set up a secure transport, which proves that ownership of that authentication domain name to the client. And an NS record is a good old-fashioned way to assert that a given server by its domain name is authorized to serve some zone. So that gives us number 2. And the last thing we need is number 3, a way to ensure that that assertion wasn't forged. But remember, we're focusing on this hybrid resolver client case. So we're almost assuming from the start that we're talking about a client that has some other resolution path to the global DNS. So if we further assume that that resolution path is over a secure transport to a resolver that's not affiliated with the local network, then that actually provides a straightforward way to resolve that NS record in a tamper-proof fashion, in a way that the local network couldn't have modified. So that's one way you could do it. There's actually also at least one other way mentioned in the draft, which is to use local Dnsec validation. So in that case, the client actually could resolve this record through the network's resolver without trusting it yet, and then use local Dnsec chain validation to confirm that that NS record is valid and that the local resolver is authorized as a name server for that zone. So I hope that gives you a tour of what some of the ideas that we've been batting around about how to deal with split horizon DNS. Mostly I want to emphasize that there are some new opportunities here because DNS security is changing and improving. So we have new opportunities to improve the security of split horizon DNS. But we do have to focus on use cases where a solution is actually possible. And we're not going to be able to solve this problem in a way that works for every network and every client. The question is whether we can find a solution that's useful to enough networks and enough clients that it's worth writing down. Thank you.
One comment before we open the mic line is the draft that was in ADD. We sort of structured this session not to be a major discussion on that draft. It has ideas which Ben has presented that's percolated up. So the request is that let's focus on the ideas and not debate the draft itself. The draft will be covered at IETF-113 during the ADD session. So let's stick to the ideas versus the particulars of that particular draft. Fair enough? All right. Mr. Lawrence, I turn the management of the queue over to you.
And first up is Paul Wouters, please. We can't hear you, Paul. Your mic is active, but perhaps a local mute. We still cannot hear you, Paul. Okay. Paul will be back in a minute. Tommy Pauly, please. Yep, go ahead, Tommy. Tommy had activated himself and then... Okay, Paul's back, Tommy's back. Yeah. Paul first. Let's try Paul first.
Oh, Paul?
Still can't hear Paul. Let's go with Tommy.
Can you hear me?
Yes, we can hear you,
okay.
Tommy.
Great, yeah. Sorry, Meet Echo had popped up a window here that wouldn't let me click on anything because it was having trouble connecting to audio. So that was useful. All right. Thanks for the presentation, Ben. A lot of people are saying your diagrams are great. So yeah, thank you for that. I had a question just on scope for the discussion. If you could actually go back one slide. Or if you're still controlling that. Yeah. So you know, I think the list of things you have here makes sense for some of the use cases, but it is focusing on the case where you know you can even try to prove that a resolver has permission to resolve that name because it's like some public zone. There are, you know, as I think you mentioned earlier, you know, many cases where that's not going to be possible. Like maybe I just have some like weird walled garden network with just some like local names of servers to like access some video content, or you know, the split DNS is just coming up with its own names, and that's possible within like the VPN case. It can just say, yeah, I'm just going to come up with whatever. And there certainly are cases where, you know, a device will want to be able to access local names that are not going to be anything that's going to be publicly attestable. So do we think that is in scope for this discussion around split DNS, since that is so common? I'm concerned that if we don't allow that to be in the solution space, we're going to miss out on a lot of cases.
Sure. So the chair should tell me when this section is done, and I should stop trying to answer all the questions that come in. But I'll tell you, Tommy, I'll tell you my perspective, which is if your name doesn't exist in the global DNS and so can't be delegated to you in any secure fashion, then you are doing DNS hijacking. you are hijacking something. If you are not hijacking an actual like .com name or something, then you're hijacking the root. And this does actually cause real, classic compatibility problems. Like it's a pain for the GTLD program at ICANN, which has to figure out like, oh, we got a GTLD registration request for this name, but is this actually a popular split horizon name that people are squatting on, and it's going to be a big mess when it actually becomes real and registered. So I think that this topic of how to handle split horizon with DNS hijacking is absolutely in scope for us. We should think about how we want to handle it and respond to it. But my personal answer to that is that I think we should respond to it by making clear that it's not something we can support, really. It's not compatible with a global DNS. And what we can do is essentially guide people toward architectures that are more supportable and sustainable.
Okay. And well, I just wanted to add that Ben is not on the spot for addressing all of these questions. This is a discussion between all of us. So I appreciate very much hearing Ben's thoughts on it, but this is not Ben's presentation that he has to answer for, right? Like
so let me ask the chairs if this. I'm happy to answer this queue, but also if you'd like me to step out and get in line, I'm happy to do that.
Well, I think for as long as people are addressing things that have come up in your proposal, I think it's great, or your framework here. That's not really the right word, but I hope you understand what I'm trying to say. That this is still a useful, that this is facilitating useful discussion to have you addressing just what you brought up. And if Tommy, if you were done or no?
I was just going to respond quickly to Ben.
Okay.
As far as, when we're talking about the things that are easy or possible to solve, I am skeptical that we'd just be able to tell people, oh yeah, hijacking a name on your local walled garden is bad. You shouldn't do it like that. That will just make them stop. And in practice, because as we have for products like Private Relay tried to handle the case where we're now doing some encrypted DNS that's not on the local network, the case of saying, all right, I can't find this name externally, I can fall back to just trying locally, is actually quite easy. And so we could say essentially, there's this whole category of things where if you can't resolve it on the public DNS and you can't get anything else, all right, try some local fallback if that's within your policy. That could solve a huge swath of cases, both for cases where it's DNS hijacking, or even if you do have permission for the internal domains, they're just not publicly accessible. And really what I think remains as the very tricky technical problem, if we think that other solution is acceptable, is dual-facing resolution, where I have a name that is in the public DNS and also wants to resolve differently on this one network because of some enterprise policy. And that's the one where we need some extra assertion.
Thank you, Tommy. Paul, we're ready for you now. Unless... yeah, we can hear it. Okay, go, Paul.
Excellent. So I did reconnect, so I'm sorry if I might be saying something that Tommy, my co-author on the split DNS for IPv2, has already said. But I just wanted to make sure we had a lot of side meetings with the AD and the TLS working group chairs and Ecker and other people when we did the IPv2 version. And specifically, even in that situation where both the client and the server are authenticated and they have a trust relationship, even on top of that, it was required that we add restrictions in a way that we could not do certain domain hijacking, to the point where that's why the allow list, for instance, appears on the RFC. So the client already has the list of expected domain names it's allowed to be overwritten when it talks to the server. People were really afraid that having this sort of blanket approval of well, you have a trust relationship, so you can send us any list of domains, including gmail.com, and we'll do it, was too dangerous. And I see that. So if you look at that, there's no authentication. That's not really true. The authentication was based on provisioning, right, which is authenticated. So with that said, it is for the non-VPN case, there is no authentication. There is no trust relationship between the network and the client, possibly. And that is where the real problem is. I think if there is a trust relationship with the network, you can do something like what the IETF-ADD RFC did with an authentication list. And you'll have to provision it, but that's fine because there's a trust relationship to provision with. If you're talking about coffee shop networks and things like that, or hotels, then obviously there is no trust relationship there, and people in general don't want any domains to be overwritten. And then, unfortunately, it becomes really do you hide this from the user, or do you let the user make a decision? And either of these decisions are going to be working badly. And I'm not sure if we have a good solution for this space in that sense. And just one last one, the public zones of something like example.com externally and internally having compexample.com or just example.com also internally, these are really common scenarios where they're different, and a solution really needs to support all of them. If we're going to limit that based on assumptions that the internal and the external network have to in some way synchronize, then I think the solution will just not work.
Okay.
Thanks.
Yep, Ben, do you have something to say back, or can we move on to Warren?
Yeah, I'll just add that, we've had a long mailing list thread on the ADD. Some people here maybe aren't on the ADD list. So Paul and I have had a long discussion on the ADD list about the question of cooperation between management of internal and external namespaces, and what that would require. I'll just note that this also talks about the need to authenticate the identity of the network resolver, right? So that's not the only interesting technical problem that this brings up. That's not the only way in which this is currently science fiction. Warren?
Kamari, no hats. So I mean, I'm somewhat concerned that a lot of this views much of the DNS sort of as a spherical cow, right? Like, this is how the DNS is described. This is how we think it all works. And so we can just do these things. And there are a lot of things that are a lot more messy. For example, DNS 6.4. DNS 6.4, you have resolvers which generate answers with the IPv4 address mapped into an IPv6 one. And it's not in any way clear that they would count as sort of authorized according to this. Point out, DNS 6.4 is an IETF protocol, and it's written up in an RFC, and it's widely deployed. There's also this sort of thing is used in many, many cases. Paul Voters said, probably your coffee shop resolver shouldn't be able to do this. And users wouldn't want the coffee shop resolver to do that, but often they would. Because if the coffee shop resolver doesn't do this, then you're not actually going to manage to get on the network because you won't get through the captive portal. So there's a lot of things which it feels like is being proposed here, but doesn't address all of the problems, and sort of feels into the hijacking is bad. If we tell people not to hijack or create some process so we can tell when they will just stop doing that. And I don't think that that's true. I also think that a fair bit of this needs sort of wider discussion. Sort of in DNSOP, for example, could have more of the, this is what we're proposing. And then operators could say, well, hang on a minute, it doesn't work in the following 37 cases. And rant over, I think.
Okay, great. Thank you, Warren. Andrew Campling, please.
Yeah, hi. Thanks for that. So two points really. One is, which was made in the chat about the risk of with some of the methods that have been discussed, leaking names, which will be a problem certainly in the enterprise space potentially. If I think it was Tommy that suggested you maybe check externally first, and then only look to the sort of local resolver if in the event of failing. with an external resolver, and that does risk leaking names, which will be a concern, as I say, for some enterprises. But perhaps a more substantive point, if to validate that that this isn't hijacking, that this is done in an agreed way, the client needs to have access to a second DNS resolver. Again, in some enterprise environments, I think they're actively trying to not allow access to alternate resolvers, and I think that's recommended practice from, amongst others, the NSA. In the enterprise environments to with, for example, encrypted resolvers to only provide access to a corporate encrypted resolver and block access to third-party encrypted resolvers. So if the validation method that's recommended is you need access to those external resolvers, that might not work in enterprise examples where they're following recommended security practices. Well, I'll stop there.
Thank you very much. And unfortunately, okay, Ecker, please.
Yeah, hi. Sort of three, I think, hopefully not too controversial points. Maybe the last one won't be. The first is that the fallback thing, that we do it as Tommy suggests, where you if you can't resolve a name, you fall back to local resolver. Is not ideal for both the reason Andrew indicated, which is that it leaks internal names, which actually I'm somewhat less concerned about. See my previous commentary about the trusting the resolver, but also it leaks external names, which I am more concerned about. So if I attempt to type gmail.com and I type gsnail.com and doesn't resolve, then that does at least a local resolver, which I don't want. And so it is desirable to and that's not a great example, but if it's like a secret label, but the main 2LD is right, then it also leaks. And so it is convenient, even if you don't trust it, to have an assertion from the local resolver the names that it allegedly controls, so that you can filter out those for fallback resolution. So if for instance, like I knew that if there was a way to tell the browser, for instance, that the local network only attempts to control things that end in corp.example.com, then when I didn't resolve gsnail, I wouldn't even try. So that would be helpful. The second point is to Warren was mentioning the captive portal. That's actually a special case that everybody's special cases. So I really wouldn't worry about that too much. The standard procedure for people for things I don't know how private relay works, but I do know how Firefox Private Network works. I know how Firefox DO works, is to do captive portal detection prior to doing anything else, precisely for the reasons you indicate. So I'm sure there are many reasons to indicate to the client that there's non-transparent behavior, but the captive portal is probably not one of them. And of course, you do have a cap port working group for this kind of material. I think that the last a thing that I'm going to say, which may be slightly more controversial, is I do agree that in principle, if I decide to advertise names for .ecker, that I'm hijacking the root, but in practice, there's a difference in that there's one might think of there being where there actually is or there's not authenticated denial existence of .ecker from the root. And so it is possible to determine in general whether or not this is a domain name which does not even exist in principle versus one which I'm merely overloading. And so one might imagine handling that differently. It does feel a little different, at least. That one could, in the end of the day, by which I mean if we had a solution, I feel like the harder technical problem is the problem of that I know you and Reuters were discussing on the list of how to carve out parts of the valid space. But from the practical matter, if the name cannot be resolved in any case, then I might as well trust the local resolver about its status, because that's all the information you're ever going to have. So I think that's probably has a more controversial opinion, but I'm less bent out of shape by that one. It seems like a policy question more than a technical question. Thank you.
Yeah, thank you, Ecker. Paul Vixie, please.
Hello.
Hello, Paul.
Good. Thank you. Good morning, everyone. Let me start by thanking everybody for getting organized around this. It's a very touchy and broad topic, and has been difficult to address, and this meeting feels like progress to me. I wanted to represent a use case that is not compatible with one of the models I heard discussed, and that model was first check the global DNS to find out if there's an answer, and then if there isn't an answer, do something. Maybe go ask that question of some locally advertised resolver so that names that aren't in the global DNS will then be lookable, upable. I recognize this as a strict definitional implementation of the split DNS problem as it has been described. The in practice definition of split DNS is more subtle, and it includes the idea of filtering results. So not just the ability to say, hey, I've got some names which aren't in the global DNS. Here's how you find them. What's actually happening, and this would account for not only enterprise, but many university, government, military, educational, corporate, and family, small office, home office. So it's a very broad, industry-wide use case, and that is the local resolver may have policy, and that may be introduced through some mechanism like RPZ. That doesn't matter. There may be policy that would say that certain names, if you query for them, should not work. For example, botnet command and control names, or certain responses that contain certain addresses or CNAMEs or MXs or whatever should not be resolved and should indicate to the stub that there's a failure, maybe a false indication to the stub of the non-existence of some global name based only on the response to the cache miss, rather than based on something that is apparent at the time of query, which would be the query name. In that case, the idea that an application doing DNS is going to consult the global DNS first and then only speak to the local DNS if the global DNS has no answer is either a non-solution to the broader problem or a making worse of the broader problem. And so I hope that that knowledge will be incorporated into the discussion. And again, I thank you for the constructive tone of these discussions.
And thank you, Paul. Welcome back, Mr. Wouters. Whose AV problems are hopefully all sorted. And he will be popping up any second. Oh, he just dropped from the queue. Well, Glenn, it's your turn.
So I was going to say, Ben, thank you for the presentation. I think the conversation sort of evolved into a more general case. So I think we'll sort of switch over to sort of the more general open discussion. A couple of things I will note in the conversations I've just heard. It would seem that whatever discovery documents that come out of ADD on this topic, we're going to need to be very clear in the materials in those documents on what use cases to narrow them down so that it's understood what is being addressed and what's not being addressed. Because this isn't a large elephant we have to tackle. This is a herd of elephants that are all slightly different. So that's sort of a takeaway I'm really pulling out of this as sort of a big picture thing that and it would be really awesome if somebody were to document all these potential use cases, because I think that the DNS world could really benefit from the long term from having that. But that's definitely on the scope of ADD in our mission there.
Well, that's what Tim Wazinski has been doing for us all along. So thank you, Tim.
Okay, let me throw up the general agenda. Hang on, I'm balancing screen sharing permissions. Interesting. I can share Chrome tabs, but I can't share other pieces. All right, there's the general agenda. So, it seems the mic cues settled down. Let's move on then to sort of this general open mic line. And here are some seed issues to get the conversation started. Feel free to pick up a different topic. And may I suggest the way to do this is to state what your topic is up front if you're doing a different topic, and then go with it. But that way we all know what the comments are coming in about. But here are 3 seed issues. Is the validation resolver's authority to answer queries for domains needed? In general, it's not something we have today in other environments, sort of. Is answer validation needed in these split DNS environments? And then getting over to the DNSec discussion. Well, generally today, DNSec is not being used in the DO53 environments. Is this different? Is there, since we're now in this environment where we've got these other features, as Ben noted, available to us now, is this time to, say, yeah, it needs to have a role here, and needs adoption. And that, of course, would, trickle down to things like clients adopting and supporting the Dnsec stuff. So those are starting questions. Feel free to go in other directions, and we'll open up the floor to discussion, which could be dangerous, but let's go, just try it anyways.
So far, it doesn't look that dangerous. So rather shocking non-stampede of people for discussing this more. Wonder if we should start pulling in people from the very active discussion that's going on the chat.
I'm finding it shocking that a DNS crowd would not have opinions.
Yeah. Well, Paul Wouters is back. Welcome, Paul.
So, okay. Hi, Paul Wouters speaking. One thing I kind of find missing so far is that I would really like to see a sort of way where a network can present a list of domains and some sort of authorization over it that it can give to the client, and then the client can, via whatever method, try to validate that list. And that I don't think there's a document that tries to do something like that. The documents that are now proposed are all trying to tie it back into public DNS. I would like, what if it's some CA certificate that signs a certificate that signs a list of domains that the client can then validate, and if the client believes that certificate can make that claim, then it can just reconfigure its network.
Okay, thank you, Paul. Christian Wiedema, please.
We have this discussion already on the chat. I was wondering whether we should make some kind of assumption about the way the client accesses the internal host. I mean, if I'm using a secret, if I'm connecting to internal.example.com, am I doing that from the public internet in a way that everybody can do it? Or am I doing that because I am connected either directly to the enterprise network or through a VPN? Because if we reduce the problem to making split DNS work for internal host or VPN connected host, then we probably have a much simpler problem to solve.
Yeah. Was there more, Christian?
No, I'm sorry, ma'am. I really think that we should have this discussion about network topology and for which network topology do we want to solve the problem.
Okay, great. Thank you. Ecker, please.
So I came in a little late this morning, so perhaps this got presented earlier, but like, I'm not sure I have a clear statement of like what we're trying to do, I guess is what I would say. Is, I mean, obviously if you use, like, I mean, in the existing world, where you just trust, your recursive resolver to tell you what to do, then like it's free to do anything it wants, which is how split DNS works in the first place. And so it seems like we're talking about two interactions of security, where that is becoming more problematic. And maybe there's more, but it'd be nice to see a list in that case. One is Dnsec, which is to say what Wooters and Ben were discussing the list, which is to say, domains which are nominally Dnsec signed, but then wish to have two views. And that, of course, an obstacle to Dnsec deployment if these people wish to also deploy Dnsec for those domains. And then there is a sort of set of like, I guess I would say non-corporate, non-default resolvers, like for instance, Trust Recursive Resolver that we use, or Private Relay, or things like that, where if you just talk to the public resolver, then you get an answer that doesn't work for the local enterprise. So are there other what other cases are there that like this is now a concern that it was not previously a concern? Because I say, it wasn't previously a concern basically at all. So like what other cases are there that need to be resolved? And it's not clear to me that those cases will need the same, have the same answer. So in particular, like I think that the answers I saw being floated around for the Dnsec exception cutout case seem like they might or might not work, but like I don't have almost no application to the sort of secondary resolver case.
Great, thank you, Ecker. Ami Pauly, please.
All right. So going to one of the questions on this, on the slide that's currently up, is validation of resolver's authority to answer queries needed? I don't think it's always needed as an answer to that. Ecker earlier mentioned a case where just having a hint is actually sufficient to do something interesting as a way to fall back. I do like the direction that Paul Wooters was going in of just saying, we kind of just need an alternate way to back up the hints about what domains should be split, and that doesn't need to be based in checking against something in the public DNS or checking Dnsec. I think that clearly translates to the VPN case, which is one of the cases that we actually already have solved. And in the VPN case, I trust this list because I trust the VPN authentication based on whatever local configuration or certificates I got from my enterprise. And because I have that, and it tells me the list, I use it. So, if we could have the list that I get from the local network be signed by some enterprise cert that I trust because of a configuration, I don't necessarily need to check anything else. Or maybe even if I go onto, like I walk into Google's corporate network as a guest, maybe there's something signed by the public google.com website cert that says, oh yeah, on this network you can use this list. That may be enough for some cases. And then for cases that are really just like walled garden public things, like I want to watch a movie on my airplane, I would argue that those cases, just having a hint list about what things this local network is authoritative for without any proof, and we just try it publicly and we fall back, that may be enough, because these aren't going to be sensitive domains. It's like, all right, you're accessing some movies.airline.net. That's not going to be something that people are going to be really concerned about leaking of corporate internal secrets.
Thank you, Tommy. Warren, please.
Thank you, Warren. Still no hats. So two things. I think we need to be really careful that we're not simply ending up solving for use cases that we find convenient. Like a very common use case in many corporations is if you join network, the guest network from your phone, or sometimes the employee network from your phone, laptop, whatever, they still want the ability to do things like intercept queries to Facebook and pop up some sort of thing saying, you shouldn't be browsing Facebook during business hours, or, sexually explicit content or whatever. And we need to be careful that we don't just design a solution that works well for the use cases that we think we can solve for, because then it's going to be really hard to get that deployed. Another thing which I think we need to be careful we don't end up doing is falling into when I join the network can tell me what things it's authoritative for, is allowed to do this behavior for, which is one of the easy ways we could get out of this, because then we run the problem of, I join company X's network and they immediately tell me that they can do interception or blocking or rewriting or hijacking, whatever we want to call it, for company Y, company Z, etc. But I mean, the main part is I think that we need to make sure that whatever we are designing is actually something that solves the use cases that people who are going to want to deploy this actually need to solve, and that we don't ignore the use cases which are just kind of icky or hard.
Great. Thank you, Warren. Andrew Camplin, please.
Yeah, hi. Warren has covered most of what I was going to say, so I agree with that. I won't repeat it. And I guess I'm reminded of those of us involved in ADD, where I think initially there was a view not to worry about the sort of private IP address issue, because that wasn't terribly common. Whereas it turned out that if we ignored it, I think that was 85% of traffic. So yeah, I think if we only solve the easy problems, then we might not really be solving any of the important problems. So I think we need to take that approach with a great deal of care.
Yes, thank you, Andrew. And I just wanted to observe that there's a discussion going on in the chat about whether things, filtering in particular, is in scope. I think part of the issue that we're experiencing here, and why this, expanded beyond the scope of ADD itself, is, we're looking at how the IETF handles this issue of what pragmatic approaches we can take to the fact that split DNS is an existing feature or bug, as you may care to define it, but it is in use on the DNS at large. And as we look at protocols within the different groups of the IETF, how this impacts all of them. And so filtering is, kind of the same thing. It's in scope by nature of the fact that it's in use out there. And if the IETF is working on protocols, it has to acknowledge that these these uses are already out there. I feel like I'm stumbling over myself a little, but the overall point is to say is the purpose of this very meeting is to understand how different uses of the DNS are being done out there. And so to the extent that split DNS was not particularly in scope directly for ADD or for dprive or for DNSOP, we're trying to figure out how to accommodate that in all of our discussions of our ongoing protocol work. Ben, please.
Hi. So I think I want to say the opposite of what Warren said. I think that we should figure out what versions of the split horizon problem are amenable to technical solutions within our architecture, and put forward solutions for them so that people who are configured in a way that we can support have a paved path to a well-functioning secure network. And I think that there are a bunch of cases here that are not things that we really can solve. They're not something we have the ability to to really help much with as the IETF. And so I think we can't get bogged down trying to bang our heads against impossible problems. We should focus on the things that we can solve. I do think it could be helpful, and maybe the right first step here would be to try to map out all of the different tricky subcases of things that people call split horizon DNS, and try to identify, what kinds of solutions might fit for which cases. I don't think you're going to see a blanket solution, and I don't think we're going to be able to solve the current majority case. But what I do think we can do is solve one case and make it clear enough and reliable enough that people who are serious about configuring their networks to work in this way have the option to do so, and maybe we can see a slow migration. One example I want to bring up here is the idea of HTTP transparent proxies. So in the 1990s, it was common to have caching HTTP transparent proxies inside your network so that people's content could be cached locally and reduce get better performance, reduce upstream traffic. It became clear that that practice was not really compatible with HTTPS. And so as HTTPS usage grew, that practice fell away. It didn't happen immediately after TLS 1.0 was defined, but it happened over a period of 10 or 15 years. And I think that we may be seeing a transition like that with the rise of encrypted DNS. Some other assumptions about things you can do in the network are going to have to change.
Right, and that goes, perhaps it was a better way of saying what I was trying to get to with regard to scope is, it's in scope to discuss these as problems, but the answer to discussing it in scope might be to say, if it's not a problem we have to solve, we just have to recognize that this is going to break this particular form of usage. But you still have to recognize that it exists. Paul Vixie, please.
I put myself in queue a few minutes ago after it was asserted that if you're on some kind of a captive network on an airplane, for example, there was not a leakage risk of you're looking for something .airplane or whatever .aero. That is, I think, an overbroad assertion. When someone is being tracked, whether for commercial or political or other reasons, the queries that they make are of interest to an audience who does not have their best interests at heart. And to the extent that that kind of leak into the global DNS can be correlated towards someone who's being tracked, it is a very important leak. And this leads me to the point about, it's not just about filtering. One of the things that characterizes the success of the recent discussions on these topics, which are very touchy topics, is to try to find something that has nearly universal agreement, at least among those willing to speak, and then try to use that as a foundation for going forward. And somebody mentioned transparency and anti-transparency, and I think there is a universal perceived good there, which is, we're in the middle of, possibly nearing the end of, but certainly in the middle of a very ugly time where on-path adversaries, whether surveillance capitalists or national security or otherwise, have had free reign in terms of trying to make us see the internet that they want us to see. I think that whatever solution comes out of this, whatever we end up recommending, whatever ends up getting deployed, if our recommendation is successful in that way, I think everyone is going to agree that it has to be done with some kind of transparency, ideally rising to the level of consent. Because if you're in a coffee shop or an airplane or a hotel room or whatever, and your network provider wants to hijack some of your traffic and answer it differently for reasons of their own. We can't necessarily agree, I don't think we will necessarily agree, that the internet should be proof against such interference, because there will be some people who don't deploy it for that reason. But we could say you just can't be doing that without transparency. In other words, if you're going to intercept traffic, if you've got policy on the network, the users should be made aware of that so that they have an opportunity to say, I don't want to use that network, or better fire up my VPN, or something. There should be a transaction there, an information transaction of this is what's going to happen if you use this network. I do or do not agree to those terms. I will or will not use the network on that basis. And that transparency element has been notably absent from the decades of abusive position by on-path actors, which have led us to this conference call. So, if there isn't universal agreement on this call about the virtues of transparency of whatever it is the network wants to do, ought to be, made apparent to the end user so they can decide consciously, explicitly, whether they want to whether they accept those terms. Then I'd like to see that discussed. But I'm going to proceed with the assumption that transparency is a universal, and I'm going to suggest that the filtering thing fits the category that Warren was talking about earlier, which is this is the way the network works. And, with regard to Ben Schwartz's follow-up, which is sometimes the network has to work differently, and it might take a while for that to catch on, but it doesn't, we're not always shackled to the way the network is used today. Some things that people have been doing will eventually stop working for, various reasons. Maybe the cost of supporting that use case was simply too complex, and so we had to abandon something, so that went over the side. I believe that in this case, where we're talking about signal diameter, where your DNS questions go is a matter of huge importance for both political and commercial surveillance activities. My Google Chromecast won't use my DNS server. It gets an address and a gateway from my DHCP server that it does use, gets a DNS server address that it doesn't use, sends everything to 8888. This is objectionable, and I think would be objectionable to almost anyone in the information security industry. But it's something Google does because of the number of trouble calls they get from people behind bad DNS in hotel rooms. And so they had to make a choice, and that choice had an impact globally on the privacy of their customers. I think that we're in dangerous waters with that. And so I think that if we're going to introduce a new signal pattern for a device on a network where it can authoritatively determine that there is policy which is coming from the local network operator, then again, maybe they'll opt out. Maybe they'll say, I don't want to use that network, because there should be transparency around that. But offering only a list of names, these names are mine. Don't ask the global DNS about them. Instead, you should ask this local thing, which will tell you about these local names. I guess that would support the NAT use case. But for me, I would very much have to offer the root name dot or the null string as the list, because what I would be saying is I care about everything. I don't want anything to go to the global DNS. I want everything to come to me. And I think that that is objectionable to various people who are working on this authoritative list of local names proposal. And that if we're not going to have that, then this is, again, as I said earlier, either a non-solution or a making worse. And we should be discussing that. I know it's painful to discuss it, but we should be discussing that because, as Warren said, this is how the network works. And the people who have to deploy this are likely to go to considerable expense before they will let outside third parties, non-contracted third parties, control the information perimeter of the signals that are on their local network.
Okay, thank you, Paul. I really don't want to cut you off, but we're down to our last 5 minutes of the session.
Oh, I apologize. Thank you.
Yeah,
thank you.
Ted Hardy and Eric Orth in queue. Ted, please go with acknowledgement that we have just a few minutes, and Glenn is going to want to do a couple-minute chair wrap-up at the end. But Ted, please join. Again, you were in queue, and we do want to hear your thoughts. Or okay.
I tried to join and apparently got a little bit cut off there. So I'll try and speak very quickly. I wanted to kind of tackle two pieces at breakneck speed. One is the question of whether there's something useful we can do here and provide an applicability statement to make it clear to the community exactly what that useful bit is and what it doesn't cover. Because I think what we've described so far is a way of providing a signal that a certain set of authorizations have occurred and a potential signal that allows you to discover both local and global DNS resolvers that say, hey, this is what I'm authorized to talk about based on Dnsec or similar. If we say, and this doesn't help you if you're doing X, Y, or Z, but say this is how you do it if this is what you are doing, I think we do get a little bit forward on what was argued for by a previous speaker, that there are certain things we can do, and as long as we're not claiming that we're solving world hunger with those things, but write down what the applicability is and understand that this does not change, that people may configure both their networks and their devices differently, I think that is still progress, right? Because we have written down a set of methods, we've agreed to those set of methods for those use cases. And I don't think that that's necessarily clear in my mind, whether that's 40-60, 50-50, 80-20, but at least we can be clear about what we can do. And I think that would be useful. I don't think it's useful, to be honest, to try and lay out all the different things people do with split DNS and to map the problem space, because some of it is very, very idiosyncratic. Like there are people who have different DNS answers based on the port you're connected to. That's not normal. It's possible, but it's not common. Mapping all of that out isn't very useful. Similarly, I think trying to take the case where filtering and other aspects of how people use the DNS are kind of being worked into the same conversation as split DNS is a bit of a problem. And I think we should continue our focus on the discovery problem and continue our focus on saying, when you discover it, this is what you get. And that doesn't tell you anything about other things that you may configure or other ways in which people may behave. Thanks.
Thank you, Ted. Eric, with the note that unfortunately we only have a couple of minutes in the session, hopefully concise.
Yeah. I'll be extra quick. So I joined the queue maybe about half an hour ago, and the discussion was on validation resolvers and cases where that might not be useful and stuff. And I think that ties really directly into the ADD charter scoping against client and server policy. I think, yeah, there are cases where clients may have policy where they either have direct knowledge of certain configuration or certain use cases where they might not want validation, and there are other cases where clients might want it. So I think it's a clear case where there clearly are cases where it is useful. So let's provide those technical solutions. Let's provide ways to say, here's the proof of the authority behind the name that's being applied to split DNS. Here's a way to prove authority behind like some name that you might trust for your network configuration. And so if we provide those solutions, I think they'll find use, and we don't need to worry about saying, oh, it must always be have this authority, or must always do it that way. That's getting the policy. We can just call that out of scope and not worry about it. Okay, that's my quick statement on the matter.
Great. Thank you very much for your thoughts, Eric. And over to you, Glenn, for wrapping up with where we're going to go from here.
Thank you, everybody. Great comments, and great comments in the comments chat session too, by the way. So logistics-wise, moving forward, we're going to get these notes out because we got a lot of chairs here. It's going to take us a little bit longer than normal because we have a lot of hands that need to go in and take a look. But so expect the notes to be available early next week. This session, of course, is recorded, and we'll get that with the secretary up and published so you can go back and rewatch all the exciting conversations we've all had. And with that, I will say thank you for participating, and we'll see you at IETF 113, hopefully in person. You never know. Take care, everyone.